Hey everybody, Ms. Gosling here. In this video, you are going to learn about our Unit 1 vocabulary. Our key terms here are distance, displacement, speed, and velocity. By the end of the video, you will be able to define, compare, and contrast these four terms. So without further ado, let's go ahead and get started. So I'd like to start by comparing and contrasting distance and displacement. So I'm going to define distance as the total length of a journey. So, for example, with this maze pictured left, if I was to start at the beginning of the maze and end at the end of the maze, and I traveled around for a while, getting lost, and eventually found it to the end, my distance is going to be the length of that red line that I just drew. So I'm going to, if I was to take this line out and uh, draw it taut like a string and hold it up against a few yardsticks, that would be the length of my journey. And that would be what I would count as my distance. So say I took 1,000 steps on this journey, my distance would be 1,000 steps. Displacement, on the other hand, is the length and direction of the straight line drawn from your start point to your end point. So my displacement, no matter how well I am able to navigate this maze, is the length of this straight line. So you'll see my distance can change based off of how good I am at navigating my maze. In other words, my distance changes based off of my route. And I call that being route dependent or being path dependent. Displacement, on the other hand, is path independent. So, for example, if I was better at doing this maze and I was able to follow this green path and get that route immediately, my distance would be shorter than that red path, but my displacement would be the same regardless. So that is our key difference between distance and displacement. In distance, we don't care about the direction you travel, and we do care about your path. In displacement, the direction matters, but our path does not matter. When I am using distance as a variable, I'm going to use the letter D to represent distance, and that's going to be a lowercase d. And my units, the standard units for measuring distance, are meters, or lowercase m. I'm going to represent displacement with the letter S and an arrow over the top. That arrow over the top is representing the fact that the direction for displacement matters. We'll get into why we do that in a later video. So that is the symbol I'm going to use to represent displacement, and its units are the same as the units for distance. Our standard unit is going to be the meter. Again, letter M. And that brings us to speed and velocity. So I'm going to go ahead and define my speed as the total length of a journey divided by the time that it took to make the journey. In other words, speed is equal to distance over time, hence why I am using red like I just used red for distance. Writing this as an equation, I'm going to go ahead and write SP for speed equals D for distance over T for time. For example, if I wanted to calculate the length of my journey, if I wanted to calculate my speed, I would need to figure out the length of my red line. So say my red line is 1,000 meters long, and I finished this journey in 29 seconds. And just so you guys know, the standard unit for time is going to be the second. Then to calculate my speed, I would say speed is equal to 1,000 divided by 29, or 34 meters per second. And this unit here, meters times second to the -1, this is my unit for speed. Velocity is the length and direction of the straight line drawn from your starting point to your ending point divided by the time it took you to get from start to finish. In other words, velocity is displacement divided by time. And I'm going to go ahead and just highlight that definition because I think it's a little bit more useful than the written definition here. Writing that as an equation, I'm going to represent my velocity with the letter v and a little arrow to represent that direction matters. And velocity is going to equal displacement, which I use the letter s to represent, divided by time. And again, my standard units for displacement are meters. My standard units for time is seconds. And for velocity, my standard unit is meters times second to the -1, or meters per second. So from my start to my finish, say this line is 29 meters. Let's go ahead and rewrite it so it's a little bit more legible. If my line is 29 meters, and it still takes me 29 seconds to travel that journey, then my velocity, v, is equal to my displacement divided by my time, or 1 meter per second. And again, we have the same units that we have for speed, but this time I need to include my direction. I'm going to go ahead and call that northeast, since I am traveling in the northeastern direction on a compass. So this is how I can go from distance and displacement to speed and velocity. Again, we're going to associate speed with distance and velocity with displacement. So we have that same relationship between speed and velocity that we have between distance and displacement. One is speed is path dependent, velocity isn't. Velocity is direction dependent, and speed is not. Now that you've learned about what distance, displacement, speed, and velocity all are, we're going to go ahead and do an example problem. So let's say that my man up here, Art, walks six steps forward. So he's going to walk 6 steps forward and 1 step back. And let me go ahead and just edit my picture so it's a little neater. So there are my 6 steps forward, and then he's going to go 1 step backwards. So if I want to figure out my distance, what I'm going to do is I'm going to go ahead and just add up the steps that he takes. So he goes 6 steps, and then he goes 1 step. So his total distance traveled is 7 steps. And that's nice and easy. We're just adding numbers. Calculating my speed, I know speed is equal to distance divided by time. So I calculated that my distance was 7 steps. The time it took to do that was 3 seconds. And so it took him 2.3. So he was traveling at a speed of 2.3 meters per second. Next, let's go ahead and calculate my displacement. So Art walked 6 steps forward and 1 step backward. So let's go ahead and say forward is positive and backwards is negative. So he goes 6 steps forward and 1 step backward and ends up 5 steps from where he started. You can also see that on the picture by looking at where he started at 0 and where he ended over at 5. And we also know that he is 5 steps forward. So 5 steps in front of where he started. So now that I've calculated my displacement and I figured out both how far he traveled and in what time, I can calculate my velocity. So velocity is displacement divided by time, or 5 divided by 3, or 1.7 meters per second. And the one thing I'm forgetting, let's go ahead and add in my direction. And my velocity is always in the same direction as my displacement. So it's going to go ahead and still be forward. And that is how I can calculate my distance, displacement, speed, and velocity. That brings us to our final slide, where we're going to discuss a couple of takeaways that you should get from this video. So first of all, we know that distance describes the length of your journey, and displacement shows you how far you are from where you started as the crow flies. So distance is always going to be at least as long as displacement, if not longer. Finally, we know that speed is distance over time, and velocity is displacement over time. speed equals distance over time, velocity equals displacement over time. And there you have it, folks. That is the beginning of our first unit of physics. Now that you've learned a little bit about what these terms mean, go ahead and take a look at the practice and give yourself a chance to get started. Best of luck and happy solving.